Start recording. Hei folkens, da går vi tilbake igjen til Python og regular expression for dagen. Jeg en litt lat person og brukte alt for kort tid på å prøve å finne ut hva jeg hadde lyst til å prate om på denne her leksjonen her. Så mitt eksempel nummer 2 egentlig sedvanlig likt eksempel nummer 1. Vi har et spørsmål her. Oh, sorry. Yeah, thank you. I also keep forgetting that this is in English. So, one more time. So, I'm a lazy person. First example was, the last example was MAC address validation, and we're going to do more validation. This is going to be an IP validation. So, the example should be really familiar because we've already done it, but the example is a little more complicated. So, we're going to learn more of the components that we need to do to get from that huge kind of regular expression that really isn't really useful for anything, and get it down to as short as possible, such that you can write this under hopefully 10 characters. I don't even remember what is the size of the proper one. It's more than 10 characters, but that's simply because I'm going to do full validation. When you're working on an editor, you're not going to do that, and I'm going to show a fun little example towards the end where how I use regular expression more to the point type of thing. Anyway, here we have our example. We have we have a little bit of an example overflow from when I played around with it last time. So we need to do the same thing as last time. So I'm just going to, the best thing that you can do as a programmer is copy yourself. And hey, look, we have a foundation. Now the character in this, kind of what we're talking about here, has to change. So I'm switching that into the /d. Now the things that I haven't talked about yet, just another little bit of Python cavity when it comes to regular expression. If you remember, I said /n is a Newline character in regular expression. /t is your tab. But who are familiar with the /b? We have a few people. So /b is something that you rarely will see used in practice because it means it's a delete character. You press the backspace and you delete the character before. Actually, it's just half the job because it just moves the character. The character doesn't actually get deleted. So if you're going to do a back character on an old keyboard and on a modern one that your guys are familiar with, you would do something like /b, go back one, then override with a space, and then go back again, which is really annoying that at one point that was how things were done. Why? Anyway, /b is still a character as part of the ASCII key set. It still has a meaning. In regular expression, it means something else because they just figured out that, hell, you don't need that. But Python, however, sees that character and it's like, hey, you wanted a backspace. You wanted a literal backspace in the characters. So if I do, and let's kind of just get my Python REPL up and going here, and I say something like print and then r/b. It doesn't, well, actually it does, well, something like that. Override it. You see that? That's kind of cool. So I take the letter R, and then I tell the text itself to go back one character, and then override the R with a space, and that's built into the string format itself. It's kind of insane that that's a thing. But hey, that's how they invented the backspace character in the first place. They put it into the Carmack, to the character set, such that you can send these things transparent over your SSH tunnels and stuff like that, and make it like easy to understand, like, hey, I wanted to do a backspace. Okay, I want to do a backspace. And when you do that on your keyboard, then it means it sends the characters backspace, space, backspace. Breathe. Okay, we're back again. So to tell Python that, hey, we're in regular expression mode, we do a little thing. We put an R in front of our strings. For those who are not familiar, that means that the text is raw. That means that anything in the inside of the string is to be considered literal. Which means that if I do, and we can do this again from my REPL thingy here, if I say print /n, then obviously it's just going to print out the Newline character. But if I squeeze in an R prefix to my strings, you get a /n. It says the slash is a literal slash and the n is a literal n, not the combined Newline character. And that's kind of important to have with you when you feed things into your regular expression engine, because there's a lot of slashes. And even the /n, which you would hope would be something you would match on, you would rather actually be a kind of a /n, because the regular expression engine process texts, and despite the fact that you're familiar with the idea that your programmer editing kind of programming language do process these type of characters for you, we're doing processing in 2 levels now. So one is through the programming language, and one is through the regular expression engine. So that means that when you write a /n, you actually have to force yourself to use the literal version. So as a rule, despite the fact that I haven't done it before now because it hasn't been required, because obviously Python is smart enough to understand that if you do a /w, which is not a reserved key in the kind of C style or bash style type of special character in ASCII, you might end up actually overlapping one of those with the /b, for example, which is a boundary character, if you remember. It's a beginning or end of a word. So if you put that in the middle of a word, actually we can show that part. RE find all, and then say R/BA, so beginning of the word that starts with an A in the string, and then we say something like BC AB BA. So the A pops up twice, but only once in the beginning of the word. And if we say BA dot, then we also get the match. Cool? Does that make sense? This is something kind of improvising here. Anyway, okay, closing my Python REPL. Going back to my example, I want the /d. I'm putting the R in front of it. For your standard IPv4 standard, we only need 4 of those. And the characters we want to match on is 3. And then we run that code. Sorry. And we get false on all accounts. There's a reason for that. First of all, this should be a dot. Oop, sorry about that. I'm making a mess. There we go. False, false, and true. So what happened here? Well, we said it should have 3 characters of D, of the character D, separated by dot, and you wanted to do it 4 times. Question?
Sorry, don't you have to escape the dot character? I mean, strictly?
Yes, that is very true. I was I was going to say that. I was getting to that, and it's in my notes. But you're right. I actually skipped it. So yes, good catch. Though it doesn't really matter for this example, obviously, because dot also matches dot, because it matches on any character, which is the nice thing about the whole thing. Anyway, in this case, it kind of matches true on the last one, but not the 2 former. And the middle one is incorrect because it's too long, but the first one is correct, which is a little bit problematic because it has fewer digits. So in the case of the last one, it matches perfectly because we're always using 3 digits. But if you're writing an IP address, you don't really want to write all the digits all the time. It's just simpler to do the human readable version where you say something like 127.001, which is how you would write it. Nobody writes it 000.000.001. So we need to kind of give flexibility to regular expression to say that, hey, we're not only interested in this many characters, we want to have this character but on a certain range. We want to kind of limit that scope. So the first one that I'm going to introduce to you is what I'm going to call the plus character. Plus is a modifier that tells that kind of the regular expression engine that the character before the character that you put into it is going to be repeated 1 or more time. So plus 1 or more. Kind of memorizing that stuff because that's the one you're going to be using the most time. Then we don't really need to repeat it. it's enough to just say, hey, I want one of those. We can print it out if you like, but it should be evident what's going on here. And hey, look what happened. Since we had the anchors copied from last time, the middle one, which is too long, don't match, which is what we want. We wanted to do the full match. But the nice thing here is the first one now is matched. And the reason for it is the plus character. We say /d to say that we want a digit, and we allow that digit to be 1, 2, 3, 4, or 5 numbers of times. So in the case of 127, it's 3, then it's 1, then it's 1. And if I say remove this character in the middle there and say that, hey, we're going to do 0 of it, then it's going to fail, as you can see when I do the testing. So, but if you would like to be in a situation where you want to do things optionally, that's also possible. The way to do that is to switch your plus character, which is 1 and more, and switch it with a multiplier. Multiplier is also one of those modifiers, which means 0 or more. And when we remove a character here and run it, the first one is still true, as expected. Kind of cool. By the way, let's fix this to be, this is what we want our test to actually do. So, okay, let's make this problem insanely much harder. I'm gonna, first of all, I'm just gonna say, hey, what if I put a 1 here? So now we're in the situation where, hey, I want it to be 1 or more, but I don't want it to be more than 3. Because, hey, I sent in a value that's obviously larger than 255, which is the highest value an IP kind of number can take as part of its address. So if I run this, it gets a true at the last one, which is incorrect. We don't want it to be true. We want it to be false. So, like the character classes, we can do modifiers for counts. So brackets, the kind of square parentheses, are the one that we use to say custom character classes. Curly braces are the one that we use to say, hey, I want to make a custom quantifier. And in here, you can kind of put your numbers, and for our case, we want something in between 1 and 3. So I made a range and say that I will have the kind of the digit /d, and I will allow it to be either 1, 2, or 3 characters long. So it will exclude 0, and it will exclude 4 and higher. And if we run our little code again, it's still failing, but that's simply because I haven't included a false here. Yep. And now it does what it's supposed to be doing. It validates perfectly for that value. Now, let's get into the technical stuff of the quantifiers. I will give out these as an, I was asked during the break, hey, will you give all the lecture notes? Yes, I will give out all the lecture notes. This is a table of all the different quantifiers. And I know, I've been introducing so many different classes and characters and everything, and it feels very overwhelming to have so many things that you need to memorize. No, you don't need to memorize these things. Typically, in practice, if you're going to use this actively, you will remember how the structure of these works and stuff like that, and the /w/d are typically something that we'll be using over and over again, and dot, obviously. But it's only a subset of a very large language, and for your assignment, you can always have your quick table available, and it will not be something that will pop up in an exam ever. As in, why would you remember everything? That's just silly. So don't worry about that. But the idea of the character classes is pretty straightforward when it comes to the custom ones. If you include just one value, that means that you want it to be exactly this long. If you say comma and nothing after, then I say n or more. So in a sense, if you skip the value with a comma included, that means it's an open range. And if you do the same thing, you can say upper limit and say, hey, n or less. That goes all the way down to 0. Obviously, negative number of characters doesn't work, simply because of the limitation of being a language. And like we kind of like I showed, and m if you want to do a specific range, which is what I wanted to do with the IP address example. Now, let's do the really kind of complicated stuff. Let's do 256. Now I'm really messing with you. This is the one that you can't really do with a simple regular expression, and it's more advanced than you will ever do. This is part of your editing your code. But it is possible to get your regular expression to match that thing. You just have to be a little bit clever about how you do it. So we're going to have a little bit of fun with that. But to do so, we have to get there. So we're going to do a little bit of a detour. I'm going to talk about a new topic, and that is groupings. So far, the character classes has been one character, and if you're going to concede the character classes here, is that this one, kind of combining things together, is A or B or C, or if you're going to be fancy about it, it doesn't really matter if you have three letters, the range A through C, which is the same thing. And if you say a question mark, which from the quantifier list here means 0 or 1, I like to call this the maybe operator. It's a nice little name for it, because I like this thing, maybe. Fits really well. So in this case here, I want an A or a B or a C, maybe. And as you can see on the matches that I've written down here, blank character is allowed. As in, you can match 0 because I put the maybe character after it. If I do the same thing for a multiplier, as in the 0 or more, then obviously you can have an insane amount of combination. This just grows exponentially. But you can have the empty character, and you can have A, B, or C, and then you have A, B, A, C, and then B, A, B, B, and so on and so forth, and so many as you want. This just explodes, and so on and so forth. While the grouping, which is the new topic here, which we haven't touched based on, using round parentheses, takes a bunch of characters in a row and say, hey, this thing is a unit, which means that if I put a quantifier behind a group, the group as a whole gets part of that quantifier. So if I say, in the simplest case, I want ABC, maybe, then I can only do 2 matches, either empty string or ABC. We have a question. Yes, and when I say 0, I mean empty string in this case. Thank you. So, and sorry, I also have an error here. I don't know if you still saw that. The multiple character is done with a question mark colon. Actually, the question mark colon is not strictly required, but it is a way of telling regular expression semantically if somebody's going to read your code later. Hey, I want to just group this character together, because parenthesis, and we're going to get back to it, is a complicated beast because it has multiple meaning. As you can see in the title, I called it groupings 1. We also have groupings 2 and 3 because groupings does a lot of things and it gets messy. But the simplest one, is just it groups characters together. So you can do quantifiers together, which makes it really nice to do stuff like this. Like, hey, I want A, B, and C in sequence, and I want 0 or more of them. How can we use this in our example? Well, we have done this join thingy. Why do we need to join? Why can't we just do D slash 1 through 3, and then we say dot, and then we do the same thing over 1 through 3, and then let's group it. Let's just say, hey, I want this, and I want to have, how many do I need? 4. Exactly 4. And now suddenly, I don't really need the whole, this thing. This can be removed completely, and this can be regex, because this is my whole regex. So I took something that was a little too long to be written down as a full regex, and I just used a new rule. I grouped them together, and it's like, hey, I want to repeat. Well, yes. We also kind of need, it's not perfect. We need the dot has to have a slash, like this. That makes more, and also it has to be 3 of them. Can you see why? obviously. So we have the /d, which is the first. And then we add on a dot and another character. And then we do that 3 times. And then you get 4 in total. So I was a little quick on the trigger finger. And as pointed out, remember my slash in front of my dots to make sure that I'm actually matching against the literal dot, not the other dot. So that simplifies things a little bit. We can also, now that we're in compact mode, I can insert the $sign. And it still fails. Well, it fails an extra time now because it's not the right length. But we want the last one to fail, remember? Which is kind of, we're not there yet. But we have at least gotten to the point where a regular expression using more rules is much shorter. It's more compact. And that's what we want. We want something that is like really fast to kind of play around with. Okay, going back to what we can use our groupings for. For groupings is, again, a complicated beast. So we're going to do another type of grouping. Grouping 2 can be used to create alternative string branches. So this is your if tests in the context of strings. So in the case of my first example here, I say that, hey, and again, why am I so bad at writing colons? Whoop. Sorry. There we go. AB or CD. While if I do multiple of them, then I can say AB, CD, or EF. And that's the only thing that can match. So you kind of group them together inside the OR situation. Question? It means absolutely nothing, actually. You can effectively do this, and it works. What it does, and it becomes a little more apparent when you get to groupings 3, which I can kind of just skip ahead and see things like that, is something called back references. And when you get to that, then it's gonna make apparent why I did that this way. And I want kind of, if you kind of deliver your assignment and say, hey, I did not use question mark colon at all, nobody's gonna fail you. But it's good practice to tell the people that is going to read your code what you intended. And the question mark colon is a way of telling regular expression that we don't want to use any other special feature than the one that I'm showing you, the grouping 1 and grouping 2. So that's what it actually means in this case. And let's see, if I do this and say import RE and say RE question mark, you get documentation for a regular expression. I obviously assume that everybody is familiar with looking into documentation in Python code. But the question mark thingy here, it's actually noted in the documentation. Question mark colon, non-grouping version of regular parentheses. So I call it grouping because that's what the parentheses are, but I'm not actually using the grouping function, which is the grouping 3, which I'm getting back to. So that's what it means. Okay, so as you kind of saw in the regular expression, there are insane amount of commands that you can use together with the question mark colon thingy and replace these two. I mean, you can get so many different features that I don't even know what they do. I never cared to look into it because it gets really, really fancy. And you don't need them. You really don't. Okay, back to our fancy little example here. We wanted to do groupings. Now things are going to be a little bit more complicated. So first of all, I'm going to just do, say, char. I'm going to go back to the char stuff because I want to just make one of them. Whoop. And then I say RF. Is that allowed? No, it's not. So I have format in char, and then I have to give the char again because I only want to make one of them. Okay, so we want to match 255 but not 256. So this is a little more in the context of complicated tasks that you don't really need to know, but since we're in the play zone of playing with that example, let's play with it. So let's just assume that the 2 first digits are 2 and 5. Then the last digit can only be 0 through 5, because you're not allowed to do 6, 7, 8, or 9. You with me? That makes sense? If, however, this is my if branch, my first digits are 2, and my second digits is 0 through 4. Then I can do, and I could say /d. This is a valid one because now we can use any type of characters. But for just kind of consistency, I'm going to get 0 through 9, which is the same thing. Oh. Okay, everybody's with me on this one. And lastly, if my first digit is 0 or 1, then I can do 0 through 9 and 0 through 9. Now we haven't solved the problem of kind of deleting characters. So in this case, I would maybe perhaps put a question mark here, and perhaps a question mark here, and then suddenly I also have the shorter characters included. You want to see if this works? Something went wrong. Yeah. I don't remember my Python syntax. There we go. Did I do something wrong here? Oh, yeah. God. Do people see what I did wrong? This thing here. So let's do this the old style Python. This is hacky, but I know, but I'm trying to save my ass here. Bear with me. There are better way of doing things, always. Okay, interpolation using old style Python. There, score, I did it. Whew, breathe, I was nervous there for a second. We got to the end, cool. So, let's get to the last part, the part that I've been holding off. The back references, the hard stuff. No, it's not really the hard stuff. It's just another example of what you can use your parentheses for. So in practice, you will end up using parentheses without the colon with a question mark. And when you do that, something magical happens. Instead of doing a match on the full string that you're matching against, in this case, if I did the string without the parentheses here, my matching string would be A, B, and /1. Well, /1 wouldn't make sense in this case because that's a command. But when you do the parentheses, and ignore the /1 for a second, that means that, hey, I want to reduce the grouping match, as in what I'm trying to search for in regular expression, down to this thing. So in this case, despite the fact that I'm searching for both A space B, I'm only interested in extracting out A. And the fun thing is that A now has a reference. You can reference back to the content of A, despite the fact that A might be one of many things, because regular expression has a number of slots where it temporarily stores matches. It's 9 of them, 1 through 9, and by the count of where you'll find them, you can reference back to it. So when I say start parenthesis A, end parenthesis, and then B, and then /1 again, that means that I want to find out what's going on inside my first parenthesis, and I want to use that as my match. So in this case, that would be ABA, and it's only ABA. But obviously, if I did something like /W /1, then suddenly ABA is a valid response, but you could also have something like EBE, as long as the first and the last characters are the same and a valid word class, obviously. This is valid, so you can do backticks. And obviously, you can do multiple at the same time. So here, matches A, matches B, matches C, and then I say, hey, I want to do the match 3, 2, and 1. And the number is referring to the first time the capturing is done. So in this case, 1 must refers to the A, 2 must refers to the B, and C gets matched by 3. Oh god, I switched them around. Now, and the reason why I introduced you to the question mark colon, finally. So if you want to mix your things that I want to group together as a group and say, hey, I want to put a quantifier around it, together with something that you want to back reference, then you can do mixing and say that, hey, I want to match the A as a group but I don't want a back reference on it. So I add the question mark colon. While I want to capture B. So basically the question mark colon is telling regular expression engines, I do not want to save this variable. And obviously all the things that I've done so far doesn't really require you to use it, but if you're going to do both of those two things at the same time, I had to do some changing. I have to just like, okay, I'm not using this one. Now the first reference is referring to A, not B. So to get this regular expression to match the end results, I have to switch 1 to 2. And you only have 9 slots. That's kind of part of the regular expression syntax. It's a /1 character. 0, by the way, is a special character in this case. So /0 means that you're matching the whole string as a whole. So you can also do that, which is a really nice thing you can do from the min command when you're kind of like, hey, I want to append something to a string. It's like, hey, remember the substitute, s/v, and then I say groups. And then I say, hey, I want to kind of append something to groups. Then I can just say /0. Because /0 tells me that, hey, I want to do the whole thing. I don't really need to do matching. But obviously I could do the more kind of grained way, kind of the explicit way of doing that and say, hey, I want to do a capture group of my whole string. And then when I do that, it does the same thing. But that's a little more cumbersome. It's easier that you have like a short key to, hi, I want to return my whole string, in case you want to do a substitution where you want to keep the content of the whole string that you're matching against. Cool. Now, let's get back to the kind of validation here. So we did the kind of char inside this little thing here. Let's remove this thing. Now we can start doing references to it, back references. And now, instead of doing kind of splitting it up, I can do everything in one go. So let's add the kind of the anchors on both sides to make sure that I'm only taking the right length. And then I say that I want, well, dot, and I want to make a, whoop, I lost my cursor here. And I want a /1 because I'm back referencing to the first time I wrote it. So we're using the principle of only writing things once and then run forever, which is the idea that I'm going through. But I'm capturing this thing as a group. Well, actually I'm not going to use that feature because, hey, I'm just going to do a multiplier on it and say I want 3 of those. And now I can remove this, and this is my regex. And I got all my regex down to this little thing that kind of does the whole thing. Okay, it's a little bit long. The example that I'm showing you here, it's a little bit complicated, and yeah, that's life. But it should work. Oh God, I'm nervous now. It matches on nothing. Can somebody see there? I don't want to. Don't want to know. Okay, I'm gonna let it be. It's I'm gonna use way too much time, huh?
Did you say, like in your example, when it was /v and you reference back to it, that it has to be like the same character? Or was that not?
What are you talking about?
It was like /w.
Oh yeah, that I need the
Does it have to be ABA when the first one is A, the second one has to be A2? Or is that not?
No, not in this case.
I think it has a colon question mark. Shouldn't it be switched around?
Oh, yes. Thank you. Well spotted. Sometimes, no, didn't help. Good catch though. But yeah, I'm gonna let it be. It's not important. It's just a question of kind of confirming my ego, and my ego is not on trial right now. So let's go all the way back to the stencil problem. So the one that made absolutely no sense in the beginning. And it's like, hey, I did the magic trick where I just switched them around. And now we've gone through all the different little tools that we needed to get around it. And we don't have all the tools, but we have a good introduction for what I can kind of give you on one lecture. We're going to have more of this next time. But we can do cool stuff. So I'm invoking my substitution command again. And now I'm going to see what I did. So remember, brackets means that there is a character class, so it's reserved. So I have to cancel it. So slash bracket means that, hey, I want to actually do the matching of a character class. And then I say, I want to capture something. In this case, I'm going to capture everything. It doesn't matter, because regular expression is smart enough to understand in this context what I'm trying to do. Well, not right now, because you can see that when I say dot star, it matches all the way to the end of the line, which is kind of what I want. But if I put a comma there, then basically the only way to match that is to reduce it down to a comma. Obviously, this is going to be a little bit problematic if I had more comma on that line. So regular expression is one of those tools that you have to insert just enough complexity to capture the problem at hand. This one doesn't have that much complexity because each line is very regular. And I can see that the concept of parenthesis, comma in the middle, and parenthesis at the end captured everything that I need to do in all my capturings. Okay? Space, then I do match everything again, and parenthesis. So now I match my kind of whole expression of what I'm trying to capture out. This kind of, my regular expression often look like this. This is often how I do things. And then I do a substitution. Now I want my parentheses back. I don't really need them when I'm in the substitution mode, the canceling. You can use them. They make no sense, but because you're not actually doing capturing at this point. Now we're doing the substitution part. So now I can write more freestyle. But instead of doing /1/2, which gives me back the same references, I'm changing the order and saying /2 and putting a comma space in between. And that's it. That's the magic. That's all I did. And now, hopefully, that made a little more sense than when I introduced it at the beginning of the lecture. Right? Right. Okay. Last little party trick. I started... don't save anything. Google had a little fun little exercise collection of different assignments of all the different things that you ever will need to do. Well, Google has a lot of things. Baby names. I'm going to go into baby 1992. And this is HTML. Imagine you're kind of familiar with HTML. Popular baby names in the kind of the year 1992, something that I might have been scraping off the internet. Google has a full list of it. And it contains a table. It contains rank, what is the most popular boy name, and the most popular girl name. And if I remember correctly, I chose this list because there I am. I'm popular. No, I'm joking. Anyway. Yes, Robert, there you are. You're more popular than me. Damn it. Anyway, so this is kind of, if you're going to talk about my day job, then data cleaning is something that you use a hell of a lot of time with, because the world consists of a lot of, let's not call them idiots, but let's call them non-programmers. In my case, my clients are biologists, and all the data sets that are in biology, it's typically it's Excel mostly, and then put into, I can transfer that into comma-separated value type of document, but it's still not systematic. It's not structured. And this is not uncommon. Like, hey, we need to scrape something off the web to get something because they made a web server. And for God's sakes, they can get Nature papers. Papers that are like the most impactful in the world. It's like, hey, we made a web page. Therefore, it's a software. As a programmer, it's like, no. But so we get stuff like this. So I could, the proper way, if I'm going to put something like this into production, then obviously I'm going to use an XML parser. But if I'm going to do like exploratory stuff, like put this into a pandas frame and just like, hey, so how would I go about do it? I want to have the table. So the first thing I want to do is let's just get it into a comma separated value. So from this kind of combines a little bit by whim, but I would kind of delete the top, and then I would delete the bottom. Did I delete anything? No. Something like that. And now I have things on a semi-structured way, but they're kind of in between. So I would then perhaps extract things used in regular expression. So percentage s / v, and it marks everything. And I'm interested in capturing a digit or more, the ranking, which is really nice. And then it gets a little more fussy. I can do fancy stuff for trying to do the TD and stuff like that, but it's much easier to just say, hey, I want to do TD and 5 of those. Nope. I want to do 9 of those. Look at that. And then I want to do another capturing and say /w plus. And then I got the boy name. And again, is it 9? Did I match it? Yes. Capturing w plus, and I got the girl name, and dot star to just get the rest. And I also want the dot star here because I want to remove all the clutter here. Okay? Deleting it, and then -1, comma, -2, comma, comma, -3. Clean. Well, ish. I did a mistake here. I forgot. Why did it not capture all the digits of the I need to have something like something like that. Nope. Why did it not capture all my D plus here? I'm reacting to the fact that you see the digits. 1, 2, 3, 4. Oh, this thing is capturing it. So I need to do a non-digit star. There we go. I have to kind of figure it out as I go along. Then I can do this and this. And I'm done. And if this is going to be a comma-separated list, then I say rank, boy, girl. And that's my magic. And now I can start parsing this into my pandas data frame and start doing means and averages and putting these into my neural networks and all the other stuff. This is how I clean. And that type of cleaning typically takes me 1 minute tops if I do it this way. Obviously, production, it will be a little more complicated. But my God, I did it with my editor, and I did it really, really fast. And kind of that's what regular expression gives you. It gives you a tool in your toolbox to do these type of things in a fun way. Anyway, that's what I had to say for the day. I hope that was enjoyable. And now I'm going to do